Something extraordinary is happening in astronomy right now. In just the past month, the James Webb Space Telescope has captured galaxies caught in a cosmic dance, detected organic molecules where none were expected, observed a planet with an atmosphere that defies every known rule, and uncovered galaxies so strange that scientists don't know how to classify them. At the same time, Webb is peering deeper into the early universe than ever before, revealing massive galaxies forming far too early and structures that challenge the foundations of modern cosmology. This isn't just about beautiful images. These discoveries are forcing scientists to ask uncomfortable questions. Are our models incomplete? Did galaxies, planets, and even chemistry itself emerge differently than we believed? And are we finally seeing hints that the universe's earliest chapters were far more complex than the story we've been telling for decades? Tonight, you're about to see how Webb's latest observations, from nearby galaxies to the edge of cosmic time, are reshaping our understanding of the universe, piece by piece. The universe Webb is revealing does not behave the way our theories predicted. According to the standard cosmological model, the universe began about 13.8 billion years ago in a hot, dense state known as the Big Bang, and has been expanding ever since. As space stretches, galaxies move away from one another. The farther a galaxy is, the faster it appears to recede from us. Astronomers measure this using cosmological redshift. As light travels through expanding space, its wavelength stretches toward the red end of the spectrum. The higher the redshift, the farther away and further back in time the object lies. Looking at distant galaxies is the closest thing we have to a time machine. But for years, there was a hard limit to how far back we could see. The Hubble Space Telescope transformed astronomy, but it was never designed to observe the deepest infrared light. One of its most distant discoveries was a galaxy called GNZ11, seen just 400 million years after the Big Bang. For a long time, astronomers believed galaxies beyond this point were extremely rare. Then, the James Webb Space Telescope began observing. Webb was built specifically to detect faint infrared light from the earliest cosmic eras, and once it turned its gaze toward the deep universe, that empty early cosmos scientists expected simply wasn't there. Instead, Webb found galaxies everywhere. Dozens of galaxies appeared at redshifts higher than 11. Some formed just 200 to 300 million years after the universe began. One of the earliest, known as Glass Z13, existed only about 300 million years after the universe began. Even more shocking than their age was their abundance. These galaxies weren't isolated anomalies, they were common. This immediately raised a problem. According to current models, there shouldn't have been enough time for galaxies to form, let alone grow large and bright. Yet Webb was seeing them already mature. And that was only the beginning. As astronomers continued to analyze Webb's data, they discovered galaxies that were not just early, but massive, systems rivaling or exceeding the Milky Way in stellar content, appearing less than 1 billion years after the Big Bang. Under the standard model, the dark matter halos required to build such galaxies shouldn't have existed yet. Something didn't add up. At the same time Webb was rewriting the early universe, it was also transforming our understanding of galaxies closer to home. In one striking image, Webb captured 2 dwarf galaxies locked in a gravitational embrace, a slow, elegant cosmic dance. These galaxies are small compared to giants like the Milky Way, but Webb revealed intricate structure, bursts of star formation, and delicate streams of gas shaped by their interaction. This wasn't just a beautiful picture, it was a reminder that galaxies are not static islands in space. They evolve through encounters, collisions, and exchanges of material, processes that may have been far more common in the early universe than we imagined. And then Webb revealed something even more surprising. In the nearby dwarf galaxy Sextans A, a system thought to resemble the primitive galaxies of the early universe, Webb detected carbon-based molecules known as PAHs, the building blocks of complex chemistry. These molecules were found in an environment extremely poor in heavy elements, where scientists believed such chemistry should struggle to exist. Yet there it was. Dust, organic molecules, and chemical complexity were forming far earlier and under harsher conditions than theory predicted. This discovery suggests that the ingredients for stars, planets, and possibly even life may have emerged much sooner in cosmic history than we ever thought. While galaxies were challenging cosmology, Webb was also shaking planetary science. In one of its most puzzling observations, Webb studied an exoplanet orbiting a pulsar, the dense remnant of an exploded star. What it found was astonishing. The atmosphere appears dominated by molecules that shouldn't be there, with a composition unlike any atmosphere previously observed. This world defies current models of planet formation and survival. How does a planet even exist around such an extreme object? And how did it acquire an atmosphere that seems to break the rules entirely? Once again, Webb wasn't just filling gaps in our knowledge, it was exposing gaps in our understanding. Then came one of the strangest discoveries of all.
While searching for faint, distant sources, astronomers using Webb's MIRI instrument detected an object so red and so faint that previous telescopes had completely missed it. It wasn't moving, it wasn't a nearby star, and it wasn't easily explained by dust. Researchers proposed several possibilities. Perhaps it was a dusty galaxy relatively close by. That didn't fit. Maybe it was a heavily obscured galaxy from a later cosmic era. That explanation also fell apart. The most compelling idea was far more dramatic. This object may belong to a newly identified class of galaxies, compact, intensely luminous, and unlike anything seen before. Similar objects have already earned a nickname among astronomers, astronomy's platypus, because they don't fit into existing categories. If this interpretation is correct, the object's redshift could be around 15, placing it just 100 million years after the Big Bang. That would make it the most distant and earliest galaxy ever observed. And this is where the implications become profound. These compact red galaxies appear far too massive, far too bright, and far too evolved for their age. According to current cosmology, there simply wasn't enough time for them to form. The dark matter structures needed to seed them shouldn't exist yet, and yet Webb keeps finding them. Some galaxies observed by Webb appear to contain more stars than the Milky Way, despite forming within the universe's first billion years. This directly challenges the idea that dark matter halos are the slow, necessary scaffolding for galaxy formation. Astronomers are now asking questions that would have seemed unthinkable just a few years ago. Did galaxies form faster than we thought? Does dark matter behave differently in the early universe, or is something missing from our model altogether? According to astronomer Claudia Lagos, the presence of such massive galaxies so early poses a serious challenge to the standard cosmological framework. Under current theory, the universe simply didn't have enough time to build them. To explain what Webb is seeing, scientists are exploring new ideas. Some remain grounded in physics, altered star formation efficiency, exotic dark matter behavior, or rapid early collapse. Others reach further into concepts like cyclical universes, multiverse models, or even the possibility that our universe emerged from the remains of a previous one. Nobel Prize-winning physicist Roger Penrose has suggested that our universe may be just one phase in an endless cosmic cycle. While controversial, ideas like this are being revisited because Webb's data refuses to fit neatly into old assumptions. As the James Webb Space Telescope continues its mission, anticipation is building. Every new image carries the potential to confirm long-held theories or dismantle them entirely. What is becoming clear is this: the universe's early years were not simple or quiet. They were dynamic, crowded, chemically rich and astonishingly productive. Galaxies formed faster, chemistry emerged earlier, and complexity appeared where we least expected it. Thanks to Webb, we are not just observing the universe, we are rewriting its story. And this journey has only just begun. Thanks for watching, and we hope you enjoyed this exploration of the universe as we are seeing it for the very first time.